Let us see one more problem on superposition theorem. What is the question given? Find the current through 10 ohms resistor using superposition theorem. So now we want to find current through 10 ohms resistor. So we want to find current through 10 ohms resistor using superposition theorem. Let current through 10 ohms resistor is I. By superposition theorem, we should take each source separately and replace other sources with its internal resistance. So at case 1 I am taking 25 volt source and replacing 2 amp source with its internal resistance, nothing but we are open circuiting this source, and 2 amp source is open circuited. Again taking 2 amp source and replacing 25 volts with its internal resistance, nothing but we are short circuiting this 25 volts source. By this if we draw the circuit looks as follows. So 25 volts we are considering. Here we are open circuiting. So this has been removed. Again taking 2 amp source and 25 volt source is short circuited. So this is short circuited. Now consider current flowing through this 10 ohms is I dash and current flowing this 10 ohms is I double dash. Now to find I dash, you may use nodal analysis or mesh analysis or anything to find this I dash. Here I am using mesh analysis or loop analysis. So I am considering loop currents. So current flow in this loop is I1 and this is I2. So from loop 1, if we apply mesh analysis, then in loop 1 the equation we get is 5 plus 15 20 I1, this I2 affecting on I1 with 15 ohms resistor, so minus 15 into I2, this I1 touching first negative terminal of voltage source, so negative 25, which is equals to 0. If we rewrite this, 20 I1 minus 15 I2, which is equals to 25. Consider this as equation 1. From loop 2, 10 plus 5 15, 15 plus 15 30, 30 I2. Again this I1 affecting on I2 loop with 15 ohms resistor, so minus 15 I1. Here there is no voltage source, so this is equals to 0. If we rewrite this, minus 15 I1 plus 30 I2, which is equals to 0. Consider this as equation 2. Solving 1 and 2, we get I1 and I2. We get I1 as 2 amps and I2 equals to 1 amp. Now here I dash is equals to I2. So here if we apply branch current, I dash is equals to I2, I dash is equals to 1 amp. So from case 2, taking 2 amp source and 25 voltage source is short circuited in this, applying mesh analysis. Then I need loop currents, so I am taking this as I3, I4 and I5 from loop 3. If we write loop equation, then 5 plus 15, which is equals to 20, into I3. Again this I4 affecting on I3 with 15 ohms resistor, so 15 into I4, which is equals to 0. Consider this as equation number 4. From loop 4, here 10 plus 5 15, 15 plus 15 13 ohms into I4, and this I3 is affecting on I4 with 15 ohms resistor, so minus 15 I3. Similarly this I5 is affecting on I4 with 5 ohms resistor, so minus 5 I5, which is equals to 0. If we rewrite this, then we are going to get 15 I3 plus 30 I4 minus 5 I5, which is equals to 0. Consider this as equation 5. Now taking loop 5. In loop 5, this current source is trouble in writing the loop equation, so here this loop 5 equation is not done. So here in this loop 5 we are not getting loop equation, so I am taking branch current such as 2 amps in this way. I is in this direction, I5 is in this direction, so minus I5 is equals to 2 amps, so I5 is equals to minus 2. Substitute I5 in equation 5, then minus 15 I3 plus 30 I4 minus of 5 into minus 2. Substituting I5 is minus 2 in equation 5, so minus 2, which is equals to 0. 15 I3 plus 30 I4 minus into minus plus 10. I am taking going this 10 to other side, so this is minus 10. Consider this as equation 6. Now solving 4 and 6, we get I3 and I4. Now we are getting I3 is equals to minus 2 by 5 and I4 is equals to minus 8 by 15. Now if we apply branch currents, I double dash in this direction, I4 is in also this direction, so I4 is equals to I double dash is equals to minus I by 15. Suppose when you fall in trouble with mesh analysis, you may use by nodal analysis. I will show how to solve by using nodal analysis also. Some people get trouble in solving loop by equation. They may not get idea of a branch current, so you may use nodal analysis, or you may verify the answer is correct or not by using another method. So I am considering nodal analysis here. From nodal analysis, I am considering nodes L and R, so I am taking current flowing away from the junction, so I am using directions like this. So at node L we are getting VL minus 0. Again we are taking this as reference node, so VL minus 0 by 5 plus VL minus 0 by 15 plus VL minus VR by 10 ohms, which is equals to 0. We write this VL plus VL by 5, VL by 15, VL minus VR by 10 equal 0. Taking 5 as common, so here 1 Here we are left over with 1 and 3, here 2. If we LCM this, we get 6 as LCM. 6 as LCM. So 1 by 6, 6 plus 6, which is equals to 0. 1 into 6, 6, so 6 VL. 3 2 ja 6, so 2 VL. 2 3 ja 6, so 3 into VL minus 3 VR. Take and go this 6 to other side of the equation, so this 6 get cancelled. Now we are left over with 6 VL plus 2 VL plus 3 VL minus 3 VR equal to 0. Now here these three terms we are summing, so we are getting 6 plus 2 8, 8 plus 3 11 VL minus 3 VR, which is equals to 0. Consider this as equation number 7, and I am taking it equations at node R. At node R we are taking VR minus VL by 10 plus VR minus 0 by 5. Again we are going opposite to the direction of 2 amps, so minus 2, which is equals to 0. Now VR minus VL plus 2 VR by 2, which is equals to 10. Taking 2 as common and sending to other side, we get this side as 20. Now we are left over with VR minus VL plus 2 VR. Here we get 2 VR plus VR, which is equals to 3 VR minus VL plus, which is equals to 20. Consider this as equation number 8. Now we get VL is equals to 2 volts and VR is equals to 22 by 3 volts. Now if you observe here current through 10 ohms is I double dash which is equals to VL minus VR by 10 ohms. We got VL as 2 volts and VR as 22 by 3 volts by 10, which is equals to I double dash. So if we solve this, which is equals to I double dash is equals to minus 8 by 15. So if we check this with here mesh analysis, so we get I double dash as minus 8 by 15. So we got answer is true. Again, this is not a final answer. Superposition theorem, we should add all the currents which are get individually. So I am taking this as I assumed this as I dash and this as I double dash. All are in same direction, so I dash plus I double dash is equals to I. Now I is equals to 1 amp. I is equals to 1 amp plus I double dash is equals to minus 8 by 15, which is equals to I. Now I is equals to, which is equals to 7 by 15. Therefore current through 10 ohms is 7 by 15 amps.